looking at some problems from section 10.5 on multiple regression. So once again, this is when we have multiple variables weighing into one result. So if we look at this section here, it's section 9 through 12, we talk about a city fuel consumption. So in the directions up here, it talks about finding the best multiple regression equations. So refer to the accompanying data, which was obtained using the data from 21 cars listed in data set 14 in Appendix B. The response is Y. Variable is the city fuel consumption in miles per gallon. The predictors X are weight, displacement, and then highway mileage. So if we kind of look at this table, it starts asking us questions, and it says, looking at this, if only one predictor variable X is used to predict the fuel consumption, which single variable is available? So do realize we have multiple different things that go into this situation. If you notice down here, they're talking about X predictors. Here it is a city just based off a highway, just based off of displacement, just based off of weight. Then they look at the combinations of two factors, displacement highway, displacement weight, weight highway, and then all three together. So what we need to do is whenever we create a table on these, we have to start by looking at each individual one. We look at two of them, and then we'll look at all three. Now if there were four of them, we would have four of one, and then we'd have four pairs, and then we would go through all the different combinations of threes, and then the one that has all four in there. So do realize that this does take some time to do, but once you have the data in your table, finding these adjusted R-square values and the equations are quite simple. So if we were to consider what's happening here in number 9, it says if only one predictor were. So if we look at our bottom three right here, we look at our adjusted R-squared value. So our adjusted R-squared value is 0.697, 0.641, and then 0.920. 0.920 is the highest, so if we were to consider any one factor in this, we would consider highway to be our best indicator of what city mileage would be. If we said exactly two factors, so two factors would be these here. If we notice we have 0.720, 0.935, 0.928. Now notice 0.935, 0.928 are very close to each other. They're both have a weight and highway or displacement in highway. We see 0.935 is the highest right here, so that would be the weight and highway. Number 11, it says which regression equation is the best for predicting city fuel. So if we consider here we have a 0.933. That's with all three being taken into consideration. 0.935 is actually higher, and that has one less. It only has two indicators in here. But using common sense, 0.935, 0.920, this is very close. So the best indicator would be this regression model where the city mileage would equal the negative 3.15 plus 0.189 times the highway mileage. This is just telling us that it gives us the best way to do it, and once again we want to have the least amount of variables as possible. Now if this was like a 0.7, then yeah, we definitely would want to come up to this one. So if this 0.720 would have been this 0.920 down here, yeah, we definitely would have came up and chose one of these two. Once again, probably this one with the weight and highway would have been the better indicator there. But that's what we go through when we do this. We got to first align all our different possibilities. Then we go through and find all our adjusted R-squared values. And then now we choose and use our predicted indicator of what's going on.